reservation. Over to you.
Thank you, Simon. So this presentation is addressing the ESA perspective on Earth, Earth science data preservation. First of all, I start with some slides showing what are the ESA missions and what we have in the ESA Earth observation program. So first of all, as you can see here, there is a set of all the Earth observation missions which are currently handled at ESA. Just very shortly, we have meteorological missions where ESA is basically developing the satellites that are then launched, but then operated after the launch by the EUMETSAT, which is another European organization. So here we talk about Meteosat and all the satellites that you generally see in the evening on the news in television. Then we have heritage missions, ERS and ENVISAT. These are the missions that now provides 2 decades of global change records and of data sets. And these data sets need to be preserved, made available, and exploited by the user community. Then we have another pillar of the Earth observation program, which is called Earth Explorers. These missions are basically missions where we have a scientific innovation on the instruments, and each of these satellites is tackling and addressing a specific domain in a specific. Yes. Okay. That's both of them. Okay. Good. And so, for example, we have one satellite which is called Cryosat, dealing with the cryosphere, another one with GOCE, dealing with the global ocean circulation, and Swarm, dealing with the magnetic fields and so on. So 3 of these satellites are currently in orbit, and another 3 will be launched in the next years. Then we have also missions from third parties, where ESA, as an agency, is receiving the data, archiving the data, and making this data available to European users. In this case, we have missions like US mission Landsat, for example, or mission from Japan or other space agencies in the world. And last but not least, we have the Copernicus missions. Copernicus, as you see, as you know, is a European space flag program which is led by the European Union, and ESA has the task in this program to coordinate the space component, implementation of the space component, and Copernicus will provide data that are necessary for operational monitoring of the environment and for security. A few more words on Copernicus. As you can see, we have many, the Copernicus satellites are called Sentinels, and we have many different Sentinels, each of them having on board a different kind of instruments. I'm not going into detail of the different instruments. I just want to show that the first satellite had been launched in April this year. It's in operation. It works very, very well, and it's already providing quite a lot of information that I will show in the next slides. Several others will be launched in the next year. So we have in front of us really a huge amount of work for launching and consolidating and putting in operation these missions. For what concerns the data access, the policy for accessing ESA data is completely free and open. So all the data sets are fully open and free for any kind of users. And the same applies also for the Copernicus data. So for the Sentinels, there is a Copernicus information and data policy that has been established by the European Union, and also this policy is based on a free and open access for all this data. As I was mentioning before, Sentinel-1A is the first satellite of this long series. It was launched on the 3rd of April 2014 from Kourou with the Soyuz 2 rocket, which is a Russian rocket that has been that is operated by a European organization, and that has been adopted by ESA in the last year. And this launch is really creating a new era for Earth observation, because this is the first time we have really a set of operational missions for the different kind of uses. And now I want to show you a very short, I don't know if the audio works. Yes? A very short video that has been produced after the launch of the satellite. The fairings, that is this protective equipment, go out of the missile, of the rocket. Here you have the separation of the first stage. So the first stage is really the engine that is bringing the satellite in orbit. Then you have a separation at a certain stage, and the second stage then starts continuing to move the satellite to the right orbit. After a while, you have then also the separation of the second stage, And you have a third stage, which is called Fregat, which is the one now with the engine activated, which is then bringing the satellite to the final orbit. So this satellite is done with these 3 different stages. Then when the third stage finishes its ignition, the satellite is separated. At the beginning, it rotates a bit, then it's stabilized, and it is basically in its nominal orbit. And then you have 3 days of initial activities, which is called low Earth operation phase, where you basically have the deployment of the different instruments, test of all the equipment to see if the satellite is working. As you can see now, what is opening is one of the 2 solar wings, the solar panels, which are aimed at providing power to the satellite, so they are fully covered by solar cells. Then you have also the deployment of the second one. All of this is done with commands sent from ground, from a network of stations that are controlling the satellite during its orbit. What you see now below, it's the SAR, which is basically the radar antenna, which is the instrument that is then providing the images. What I did not mention is that Sentinel-1A is a SAR mission, so it's basically providing SAR images of the Earth. And SAR is an instrument which is able also to take images when it is cloudy, so it's not like an optical instrument that when you have a cloud, you take the picture, but you see the cloud. This instrument is able to go through clouds, so it's a night and day instrument, and it's an active instrument, so it's also working night and day. So that was just to show what's the process of separating these components. On board of the satellites and on the rocket, we had installed some cameras and some. So this, for example, is a real picture that was taken by Sentinel-1A during the deployment of the wings that I've shown in the animation before. So we were proud to say that this was the first ever Earth observation selfie that was done by a satellite. And these are the first kind of results of the utilization of the satellite. So the satellite is now in operation. The 3rd of October, we have activated the open access to all the users that can access now the data. After the launch, you need to have some time. This is called commissioning, where you have to check and to test and calibrate the instruments and all the other equipment. This calibration and this commissioning phase has been completed now. So now, from an open accessible portal, every user can simply register and download the data. So this, for example, is some data that was acquired in Bosnia and Herzegovina after a flood. So this has been activated by one of the Copernicus services, which is the Emergency Management Service. So basically, you can see that this is the area in Bosnia and Herzegovina that was affected by the flood. This is the SAR image taken by Sentinel-1A. As you can see, the black part is the part which is where water is currently, so where there is the flood. And this is the kind of product, so thematic product that is generated by the Copernicus services, which is the main client, the main customer, let's say, of the Copernicus satellites. And this is the kind of product that is generated and is then provided to civil protection and public organizations for the actions that had to be taken after the disasters. And we have many examples of this. This is just another interesting application that is related to earthquakes. Through SAR and doing interferometry, you are able basically to take a picture of the earthquake. The different colors, the area with colors is basically where the earthquake happened and where there was the motion between the 2 different parts of the Earth. And this is an earthquake that happened in August in the Napa Valley in the US. And so Sentinel-1 was able to get this picture and basically make a picture and an image of the earthquake. This is very important for many applications in this domain. This is also a nice thing. It's basically an interferogram done with 7 different data takes of the satellite. The different colors in this case it's different in height. So, for example, there on the bottom part you can see the Vesuvio volcano, and all the other colors is basically different in the height of the thing. What is different with respect to the previous satellites is that you can do this kind of thing systematically. So with this kind of application, you can, for example, systematically monitor subsidence and movements in the Earth, and this can be done systematically with a 12 days period, which is something which is not that is unprecedented at this stage. So going more and talking more about data preservation. So now we have in the ESA archives, we have something like more than 20 years of continuous measurements from ESA missions, and even 30 years for some parameters exploiting data from US missions and other missions that were launched before the ESA ones. These data are becoming really an essential tool for Earth science. And in particular, long-time data series are needed for several different applications in the Earth science domain. Here you see this picture is basically just showing the sea surface temperature, which is measured starting from some instruments. But what is important also is to measure the variation in time of these components. And Fulvio this afternoon will show another couple of examples of this. This is, for example, related to sea level rise. These measurements are taken from several different satellites from 1992 to 2012, so it's basically 20 years of measurements. And from here you can see that there is a growth in the sea level rise. So this is just an example. This is one of the fundamental variables that has to be monitored. So in order to perform these kinds of measurements, what is difficult is the fact that you need to duly preserve the data, the knowledge associated to the data, and you need to have an harmonization between the different organizations and the different entities in the Earth science and Earth observation domain, because you need to be able to compare data from different missions. As you can see on the left, there are different missions. Some missions are from the US, some are French, some are from ESA. So you need to have coordination and the same approach in preserving data and knowledge between the different organizations. This is another example, again, of time series. So it's basically 30 years, because this is starting in 1980, and it's showing how soil moisture is changing. In some cases, you have the soil moisture means how much water is present in the soil, and this is a very important parameter for soil geological activities, hydrology, agriculture. So where you see the blue is related to the fact that when high blue peaks means that there is a flooding, high red peaks means that there is a drought in this area. So again, this parameter is really very much linked to agriculture, for example, that has an impact on societal, on society, of course. Last example, South Hemisphere ozone hole. Again, you need to see and to monitor how this changed over the years. So, in conclusion, continuity of data is fundamental for observing and understanding all these parameters. So now we had this first satellite that provided 20 years of data. The Sentinels will provide many other years of data to continue this kind of measurements. What is important, of course, to say is that preserving only the data, only the bytes, is useless if you don't preserve also the knowledge. We call it, also in Earth observation, we call it associated knowledge. So all the information that is related to the data, where the data has been generated, what is the provenance, how they've been produced, how they've been calibrated, what is the quality of this data. All this information is crucial to make sure that scientists can use the data. And as I said, basically data, Earth observation data are unique, first of all. They are not repeatable. So when you pass in that moment on that area, the opportunity to take the data it's unique. So you are not able to repeat these measurements at that point in time and in space. So this is really a peculiarity of this data. They constitute a humankind asset. We have already some of the data sets. Here you see in the Landsat program, so the US mission that is part of the Memory of the World, so the UNESCO heritage. As I've shown in the previous slide, they are fundamental for monitoring global change, climate variables, and also to define policies and actions that are directly affecting human lives and the world economy. So this is not only related to scientific research. These measurements, the availability of these kind of things has really an impact on the world economy. They are supporting several commercial and scientific research applications and activities. And they have an incremental value as they are combined together with data from other sources and other disciplines. So now, really the capability and the possibility to merge and to use this data together with data from other disciplines can even increase the value of this data. So as a conclusion, they need to be preserved also together with all this knowledge. Of course, this is not an easy task because, first of all, the volume of this data is increasing exponentially. So really, we have now in our archives at ESA something like 7 or 8 petabytes of data, but really the trend is going with an incremental, an exponential increase, mainly due to the Sentinels that have a volume quite huge with respect to the old satellites. The variety. So these data are not the same. We have data from many different instruments. All the data from an instrument are different from the others. They have different formats. They are of a different type. They have different storage media. So really, the complexity in Earth observation is related to the heterogeneity of this data. And then the velocity. Data are really arriving at a fast rate. So the tide of data, it's really true, and it's really happening in Earth observation. So at ESA, in order to tackle this, we have a dedicated program, and we are basically aiming at preserving the data and the knowledge, and with the assumption that we can never anticipate what can be done with this data. So in the past, we had several examples of new discoveries we have done with data in our archive, and we didn't know that we could have done this kind of measurements or this kind of discoveries with this data. So for example, it's one example I don't have here, was related to one thing that we were archiving in our archive that was a noise measurement for an instrument. So it was basically noise. So for us, it was a measurement that was needed to better calibrate the instrument. But then looking at the noise as the source of as the real measurement, we discovered that the South Atlantic anomaly was moving, for example, from the ocean into South America. So looking at noise as measurement, we discovered that the movement, the shift of a parameter that was not the target of the initial observation. And we are pretty sure that we might have many other kind of discoveries like this with data that are currently in our archive, but not used for this purpose. So the idea is try to keep all what we have in the best way we have, because we might have in 20 years, 30 years, new users using this data set for doing things we are not able even to think today. And also what is important is the valorization of the data, so to make sure that these data are fit for contemporary purpose. So we have to continuously valorize this data through reprocessing, evolution of the algorithms, and trying to make the old data aligned with the new ones and able to be part of time series of data. So as I said, we have a dedicated program for this, and we have a lot of cooperation activities in this program. Some of the cooperation activities are also done with the European Commission as part of this of the project we have, the FP7 and in future Horizon 2020. But we have also very good harmonization and coordination in Europe with all the other space agencies, plus also with CEOS, which is the Committee on Earth Observation Satellites, which is the committee which is putting together all the space agencies all over the world. So there are specific activities dealing with data preservation that I'm coordinating there. So there is also very good coordination and collaboration in this domain with agencies all over the world. And then in the second part of the program, we are really dealing and consolidating our data set to make sure that these data sets are well preserved, discoverable, and accessible to users. Because one of the difficulties I had in my organization is to make people understand that preservation doesn't mean keep something safe in a cupboard or in an archive. That's the first part. But then you need to make sure that this thing is discoverable, accessible to user, and fit for their purpose. So it has to be new, it has to be updated, it has to be valorized in a way that the users can use it. And it took some time, but now people is starting to better understand this. In terms of international context, and I think this is one of my last couple of slides, we have, as I said, cooperation with the EC, through EC project, SciDPS as an example. Then we have this working group and activities in CEOS. We have much stronger and much close coordination in Europe with all the European Space Agency through the GSCB, which is a ground segment coordination body, which is a body coordinating all the space agencies in Europe having satellites in operation, Earth observation satellites in operation. We have also activities in GEO, which is the group on Earth observation, which is basically this initiative at worldwide level to set up a global Earth observation system of systems. And again, there we have activities dealing with data preservation. We are, as ESA, members of the APA. That's why we are here today. And also we have linked with CCSDS and standardization organization to make sure that some of the outcomes of the work done in these cooperation activities is then feeding the standardization domain. So for example, we have now some activities together with David and CCSDS for standardizing preservation workflows, procedures coming from the Earth observation domain. And that's my not my last slide, but okay, this is basically showing the time series we have today at ESA in terms of satellites. So as you can see, we start from 1978 with the first data set. This data set has a quite nice story because it was 2 years ago, it was basically in a tape in an office of a colleague. It's the first SAR that was ever flown, so we can say that it's the father of ERS, Envisant, and Sentinel-1A. It's an American mission. It was basically, we had some data holdings that were in this tape, not usable, not accessible, so I took the tape, and 2 weeks ago we completed the full reprocessing of all the data set. Just as an example, at that time, to process one image, we needed 1 day to process just one image. We processed all the data set in 2 days now with the current technology, but it was difficult, very difficult really to recover the data because we didn't have any knowledge of this mission because it's more than 30 years old. So people has retired and so on. So just to understand the format of the data, what was in the tapes and so on, it was very, very difficult. So it required quite an effort and very good cooperation with NASA that provided some information, but it's a good success story that will come out in the next months. So this is basically to show that what we are trying to do is really to have long time series of data for many different applications. Of course, we have in the ESA ground segment many different functions. Each function is dealing with a specific task: management of the mission, consultation with the users, operations and programming of the satellites to tell the satellite basically what it has to acquire where, data acquisition planning, reception of the data, processing of this data, archiving of the data, and also making the data accessible. So all of these are functions, and I could make a 30 minutes presentation for each of them, but what I just want to say is that all of them have also to cooperate and work together to make sure that we meet the data preservation, discovery and access objectives of our programs and of our activities. And with this, I give the word to Pier Giorgio, that is providing some explanation of the research and service support, that is one of these functions that is supporting ESA activities in many domains and also supporting the data preservation goals. And I will respond to any question later.
Thank you, Mirko. So, okay, my task is now to bring you now down to earth and to view the problem from another perspective, that is the user perspective. So Mirko has presented the wealth of information that we have collected during last 20, 30 years. Now, from a user point of view, the variety and the volume are big challenges. We are talking about terabytes and terabytes of data. And so how do we favor services and science and research on this large amount of data? Does everyone has to invest in huge infrastructures to store and process this data? The reply is no. We have set up a research and service support that somehow has the mission to support the Earth observation community in exploiting this wealth of information. That means for what concerns the scientists, the researchers, in developing new algorithms and applications, and service providers in generating and delivering value-added information. This service, therefore, supports data provisioning, that is, making the data available to the interested users. And when we say provisioning, doesn't necessarily mean giving them a bunch of disks, but making them available somehow in a virtual way. That is what we do. We provide the data in an environment where eventually the user provides his algorithm, and we put together data and algorithm without shifting necessarily or shipping the data. So data provisioning, access, processing, allowing scientists and developers to benefit from the resources made available and acquired and preserved during the time, consisting of dedicated processes, specific know-how, scalable infrastructures, and of course, massive data archives. So on one end, we try to ensure that the research process is effectively and efficiently followed. And on the other hand, to support the exploitation environments which are being built. We have seen this morning the presentation of AGI, and in our terminology, if you wish, this federation of resources are somehow exploitation environments, enabling the possibility to generate scientific products designed around specific requirements. So in order to do that, this service has to cover a number of activities. The first one is, as we said, provision data and resources, support e-collaboration, scientific and exploitation environment, support the development of pilot environments, and the systematic or ad hoc extraction of information, the service chaining and provision. So somehow the service that we have to set up not only can provide the data and the resources if needed, but as well provides advice on how to set up a specific environment. Because of course we want to favor the fact that in Europe we have plenty of initiatives, either at institutional level or at industrial level, which foresee the exploitation of the wealth of information that we have acquired and we are preserving. Support to application and services, to the development and service provision as a result of the cooperation among researchers and scientists or between value adders and service providers. Support to the delivery, the development of information-based services based on the information extracted from the real-time or the archived data. And last but not least, testbeds and reference systems. Whenever you do science or you do services, you need to qualify, validate the quality of the research or the quality of the service. So testbed and reference systems are a fundamental part of a service delivery. And support the developers with test and validation, pilot projects, and so on and so forth. Now, this picture focuses, this drawing focuses more on the scientific aspects. On the left side, you see our abstraction of the scientific process from the question definition to the hypothesis formulation up until to the publication of the results on papers and on scientific conferences. And you will see why I mentioned this aspect specifically later on. On the second column, you see what the service that we have been set up is actually providing. So we cannot provide support to everything, and if a scientist has to invent something new, the question and the hypothesis are his own core business. But let's say the service that we have set up helps him in identifying the information on the resources that are available, the data which is available, the way of processing the data, the support to data analysis, and as well a support into e-collaboration. Let's say that the service model goes through 5 different steps, which start from basic support services, which are really the identification of the resources and the basic provisioning of the resources. Some development support services, which are the help in the algorithm setup, in the processing setup. The processing support services, in this case, are really a support in the actual processing. We arrive to the point to providing to the scientist or to the service provider the possibility either to run the algorithm itself, or since we have very challenging scientists which say, I want to process 10 years of data, we can offer even the possibility of them that a dedicated team makes for them the processing, and they get only the results. The support to the product validation, this is a fundamental step in any of the two branches, either scientific or commercial. And last but not least, the production and service support. Now, this is an example of the infrastructure from where we started, and a list, sample list of some of the data holdings which are available. This is a snapshot of the graphical user interface, a snapshot of the data holdings which are available in current infrastructure. We are, of course, moving towards the use of cloud-based resources and grid-based resources. And we are going in a direction where we would like to branch this activity then to bridge towards the Copernicus exploitation, since we have quite a number of requests in that direction. Let's say why this support is important, and we have made a case study on one of our Explorer missions. So the Explorer mission are the scientific missions. And here we have a snapshot of the number of papers published on a number of international missions. So there are European missions like Envisat, long-stand missions from the United States, like Landsat. And my example is now making reference to two experimental missions, Gauche mission and the SMOS mission. And now, which is the difference, and how we computed the difference and the influence of having such a service on the number of publications that are associated with these missions. So we used as a benchmark the IEEE publications, and what you see is that, let's say, the SMOS missions for which, let's say, the service was made available as a much higher number of publications, which, with respect to other experimental ESA missions, which were not present and were not visible, for which this environment, this support to the scientists was not available. So somehow the number of publications as an indicator of the usefulness of making a proactive service in support of the scientific exploitation of preserved data. So now, as Mirko was already anticipating, we need somehow to open our view towards other elements that characterize the data, like the temporal dimension, and this is an example of support provided to make a temporal analysis to the multispectral sensor which was flying on the Envisat satellite. So big data and the tools, the methods, and the access to big data is becoming a crucial aspect of preservation of large amount of information from space. And it's my pleasure to invite you to attend to the conference on big data from space, which will take place from 12 to 14 of November in Frascati, which addresses quite a number of different data sources. So there is the Earth observation community, of course, very strong and present there, but there is the space science and astronomy community as well, very much present. There is the climate change community, which is present. There are quite a number of presentations on the use of GPUs in order to process a variety of data. So this is somehow a multidisciplinary conference. Already 300 people registered, and I think this conference will give a picture of the state of the art of the research and challenges in big data exploitation and management. So just a last slide to summarize different technological directions that eventually somehow interact with the digital preservation. At the same conference, Big Data Conference, there is an invited session on crowdsourcing. The Internet of Things, of course, is an important element. Cloud computing, big data, and new generation of mapping tools and social networks are all areas which need somehow to be followed and technically addressed. So thank you very much for your attention and this long presentation. Any question, we are available.
Right, so next, after the presentation of the perspective from beyond the Earth, as it were, we now have the perspective of the surface of the Earth, the inhabitants of the Earth, the global perspective, and that's going to be given by Professor John Wood, who's the co-chair of the Research Data Alliance, as well as being Secretary General of the Association of Commonwealth Universities.
It's good to see some old friends, and Juan was reminding me that I spoke at the APA conference 10 years ago when APA was launched, and you all look a lot younger than I do now after 10 years. It's been a very exciting couple of days here in Europe, especially in Belgium, because yesterday there was a meeting of the European Research Facilities General Assembly. That's all the big labs around Europe, the big projects, and they were discussing this very issue about sharing of data amongst themselves, and very much focus on how we can actually provide economic input to the European member states by doing this. Today I've just rushed back from Leuven, and I'll be going back there straight afterwards because the European Commission are running a consultation exercise on the future of what they call Science 2.0. I think it's now going to be called Open Science, which is a lot better term actually. And I was listening before I came today to a presentation by Liru, and what are their two major priorities? Open access to publications, open access to data. And even the last priority, which was about citizen cyber science, still got a 75% yes vote. So we're on the cusp of a wave, it's all happening, and the Commission itself have made this one, the whole area of open science and open innovation linked together, of which data is the fundamental part, one of its 5 key activities for the next 5 years under Horizon 2020. So the policy documents are being produced now, and that's why I got to rush back, because I'm, as you can see at the bottom there, I'm the spokesperson within the high-level group advising the Commission on all these aspects. So I can bring you right down to earth because you've been up in space, and of course that's a great example of what we're all about. I mean, it just is a fantastic example, and Copernicus is a great example of one of the activities that occurs under the Research Data Alliance Europe, normally Francois Genevieve makes a very strong case for this. But can I just tell you that Research Data Alliance actually has 3 components. There is the Research Data Alliance Foundation, which is the legal body, which Juan and I put together, mainly Juan, I think at the end of the day. And that is the governing body, which does all the administration, brings everything together. And I co-chair that with Fran Behrman from the US. Then there is Research Data Alliance Europe, which is all the activities going on in Europe. And then there are individual projects like Copernicus, which come underneath that. So you may come in at any one of these stages. I'm going to talk about the global stuff and put in a bit of context. So I'd like you to meet my boss. My boss happens to be the Queen of England on the left, if you didn't recognize her. I'm in the background there, providing the amusing stuff. And of course, why are we doing it? For ladies like Malala there, who won the Nobel Peace Prize, that she can have a decent future and a decent education. So that's why my organization exists. It's 101 years old, and we'll see you out still. Okay, this is a slide that Tony Hay shows that how science is changing as we move away from experimental. Well, we don't move away from experimental, we still need that. None of these steps disappear, but they will build on one another towards e-science and data science at the bottom there. And I think we're at a very early stage in how we understand this. I'm going to come on to something in a little while, but I think it's a fundamental talent that we need to instill in youngsters from the day one almost. But really, this is the way things are moving. There can be quibbles about exactly how it's defined, but I think it's quite a good way of seeing that we've moved away just from computational towards the users using information. Of course, it's all made possible by things like Xeon. This is already out of date. I've just been down in South Africa. They're anticipating next year a 100 gig line up the west coast there. And that's there for the square kilometre array and other things going on. And I've also just been advising the South African government on their research plans, which are data intensive. So they've not only got the square kilometre array there, they've got other projects in the areas of biodiversity, and would you believe it, in the area of paleontology, which I'm assured generates an awful lot of data from the X-ray tomography results that come forward. So there, right down there, you've got what's called the cradle of humankind, right through to the latest stuff in terms of telescopes. And of course, connectivity to these regions is really important. This was a project, I think 2 or 3 years ago, linking Europe to Southern Africa, and again, the impact it's already having on research and education. So we now suddenly become a global player. I got into trouble with the European Commission when I used to have a slide saying, what can little Europe do? I still ask that question because we're part of a global trends that are going on. Well, one of the key things here is that we really are talking about research infrastructure. And as I will say a little later on, the whole concept of data is itself a research infrastructure. And it's very fundamental to many areas. And this is a slide we're using now, indeed, with CERN, to show how we can drive much more towards the economy in the future, because there is a very distinct change in the priorities of the European Commission. And Horizon 2020, some people are saying, should be the last project that funds research. We've actually got to show what comes out of it. And it's a stark reality, and people like me, and I hope you will realize that, because Juncker's #1 priority is jobs. And innovation and growth come later down in the thing. But the #2 priority is the digital economy. So we've got some hope there. But we really do have to prove ourselves, and it's uncomfortable. And certainly one thing that the Commission say to me is, you've got to show this works, otherwise we're dead. Okay, well, we produced the first roadmap some time ago, and it's going through its various editions now, but I think we got the message over, and there will be a big conference in Rome in December when the Rome Declaration about data in terms of research infrastructures under the Italian presidency will be submitted to the ministers attending that conference, and it's likely to be a very big political impact. But you know some of the projects that go on. We go from the diverse and very small data sets that are spread everywhere in the area of social sciences and health and so on. We've got things like Clarin, which is one of the great examples of how humanities get involved. And then we move on to the biodiversity types of projects, and then we come to the biggie, the square kilometre array, which is, as you will know, is spread over quite a large part of southern Africa and Australia, or will be. I had to put that in the bottom up there because 14 countries out of 54, it's not quite a quarter, is it, but of the Commonwealth countries are actually participating, either because it's on their site, on their land, or whether they are taking part in the experiment itself. So it's huge projects like this that are driving things forward, but it's also the little diverse projects pushing forward. Now, you've probably seen these before, but I like them. But just to give you a bit of a shock, this is from their website. The data collected by the SK in a single day will take nearly 2 million years to play back on an iPod. So don't bother to buy an iPod. It's not really worth it. But this one I really like is you can tell whether your plane's been delayed 50 light years away. Since I can't even tell when it's delayed 20 miles away at the moment, that's going to be incredibly useful. Of course, the real object is to look at the southern sky. But this is the frightening thing, is how we're going to cope with all this stuff shooting around. You've seen the data sets from the ESA projects. They're going to pale into insignificance in some way compared with this. This is a slide, a paper I found in Doha 3 or 4 years back. But people, even the economists and financiers, are realizing that there's something to be made in data. Not necessarily, I don't know who the expert is. That's him if you recognize him. The big driver so far, though, of course, has been CERN. And I've just started working with CERN on a number of these projects. But, you know, they are in the business of churning out petabytes of data, more data per year. They'll be up and running again. They've just got some of the accelerator parts going again. It just started up, and they'll be up and running again next year. But they're pushing out about 20 petabytes of data a year, probably a bit more when they get up to high energies, and that translates into 50 petabytes of data, and they're able to handle this. Organizations such as RAL do know how to handle some of these things, but we're moving up 2 or 3 orders of magnitude now. And the real question I have, and this is another Microsoft slide, I do apologize for that, but I think one of the things is you've got to see what it's like at the coalface. Some of us still have students and postdocs who've actually got to face all of this. And at the moment, we just rather assume, I think, that they are just going to meander into doing it. And of course, that isn't true. This is so huge. When I was an active researcher, I used to take hundreds of diffraction patterns, electron diffraction patterns, and we sat down with a big mapping table and measured them all out. We could do that. It was quite easy. I had 10,000 glass plates, and I threw them all away in the end. But now, the volume and where it's coming from, and the fact you don't know always what the provenance is a real issue. So about 3 years ago, we produced a Riding the Wave report, and we are now just producing the next edition of this, and it will be out, where are we now? It will be officially launched at the Rome meeting, but it will actually be out in about 4 weeks' time. And it's called Harvesting the Data? Something like that. Anyway, it's going into production at the moment, and really what it is to show what we've got from investing in this. And one of the key things that's going on in the Commission at the moment is that there is now a division of labour between DG Connect, who are providing the infrastructure and who have been at the vanguard of funding a lot of this up until now. It's moving over to RTD, and that's where the really big bucks will be. And so the program I'm talking about down in Leuven at the moment is about the RTD program. The DG Connect program for 16-17 is already set. The RTD program in this area is not set, and we've got till the end of the year to set it. But, you know, we talked about global collaboratives. We talked about the data itself becoming infrastructure, and the public had to have access to it. So it has a major impact not only on the science, but on the very nature of democracy itself. This is big, big stuff. But there are big issues which are difficult. Open access has to be there, and we've just been talking about that this morning, about what do we mean by that? What is the provenance? Can it be trusted? How do I know if it's been corrupted or not? Is it really accessible? Or do I have to, as you were saying earlier, go right back to the original data and try and sort out what it was without any information? Who am I dealing with? The whole legal positions and certainly personal data, how can we handle this? But I think the bottom one is actually even more important. How do we teach and train in this global environment? And one of the things that will be in the new report, the Harvesting the Data report, is that this should be back at primary school. Okay, so you have language literacy, you have mathematical literacy, what about data literacy? And actually making it there. It's almost too late by the time you've got to university. So we're looking at that. And one of the things that I've done is commissioned a report from Jamal Salmi. And if you don't know Jamal, he's a wonderful guy. He used to be head of higher education at the World Bank. He's looking at the whole career structure of what will happen in this environment, how you reward scientists for collaborating in this way and sharing stuff, and how careers will develop. And he's also going to go right back to schools and see how this can be a timeless or timeless thing of just how you do it. So one of the things we're looking at is trying to persuade the European Commission to set a cross-European project for schools under H2020 to look at some of these issues. The other report we've got, and I can't tell you who's going to write it, is what is the ecosystem going to look like? What are the business models going to look like in this environment? So this is Nelly Kroes, who's now just about, or has stepped down as the Commissioner for what is now Connect. Knowledge is the engine of our economy, and data is its fuel. Remember that. And then, so out of all of this lot, we produced a Research Data Alliance. It was about 2.5 years ago, some of us got together and essentially said, let's get on with it. And so the Commission under DG Connect, National Research Foundation, and the Australian government put 3 of us together and said, do it. And then we had wonderful people like Juan and Andrew and Peter and lots of others did all the donkey work, but the first year setting it up was an absolute nightmare, if I'm honest. I don't know how many late night phone calls were going on each week. It was but we've done it, and now we have a foundation, a legal structure, and we're underway. And of course, the real driver is not the fact that we like to share everything. It's actually there are big challenges out there that we actually have to tackle. And by bringing together fragmented domains, that's about what it is. And you know, not everybody likes collaborating. When I used to run a university faculty, I had a Woods rule, which has never been broken, that 1/3 of academics love working together and sharing. 1/3 can be bribed with money, and 1/3 will never work together. So you're talking about this isn't going to be universal. It's going to be for hopefully a large segment of the scientific community. And back in the in the European Research Area Board recommendations, which fueled Horizon 2020, we said about 1/3 of research should be going into this general area of tackling grand challenges by sharing. How does it work? Oh, sorry, it's been changing things. It very much is a bottom-up organization, but you do have to have some top-level knitting together to make it work. And so we have, I don't know how much of this one you've actually mentioned, working groups and interest groups, and we come together every 6 months on these plenaries. We've just had one in Amsterdam, and the next one's going to be in San Diego in March. And these are incredible events. First of all, I feel quite old in them, but that doesn't really matter. But there are lots and lots, all these groups just get together in little huddles everywhere. So there are very few speeches. There are little groups, we've had them sitting on bean bags and all the rest of it. The dynamics are really amazing. So it's community-driven, and it's very much on building societal, organizational, and technical infrastructure. Juan, with Walter Stewart, runs the organizational advisory board, and Beth Pla and, is it Andrew? Andrew Twillor run the technical advisory board, and I, with Fran, run the actual foundation itself. But it's not about reports. The last thing we want to see is more reports. We want to see action. And that is proving quite a challenge. Again, here we are, have the interest groups, what they do, and the working groups, what they do. And the working groups are about delivering stuff that can be used. And one thing we ask is for evidence that this stuff is being used. It's not just some sort of computer nerd having a fun time. And they only have an 18-month lifetime, and they have to deliver something that people actually want. And here are the interest groups as of yesterday. And you should be able to find something in there that might interest you. But what we are starting to see is more and more user communities. You can just see at the bottom there, I don't know what toxiogenomics is, but I'm sure it's very interesting. Must be to do with poisoning and genomes or something, structural biology, but you'll find in there stuff on marine. And I think the next slide, yes, shows you some of these that are going on. The one I really like here is the bottom right one, which is about increasing wheat yields in arid regions. And this is part of the agricultural interest group, which is here. And you can see at the bottom, wheat data interoperability in close collaboration with the Global Wheat Initiative. Now, if you didn't know there was a Global Wheat Initiative, join the club. But actually, this is about feeding the world. So, you know, we move away from the theory, as it were, to reality. And this is where the reality really is. The other one is the omics group. They are huge. They're vying with the square kilometre array in terms of the amount of data they're putting in, but it's coming from all over the place. I should that agricultural one goes back to some of the Earth observation data, because they're interested in water, in terms of climate change, sea levels. I will say, in my own organisation, I've got a large number of island states, such as Mauritius and Seychelles and the South Pacific. They are very, very interested in how that water is rising, I tell you. But I think this is the sort of example where Elixir is working with the biosciences groups, the biodiversity groups, the climate change people, as well as the more fundamental structural biology. These are the countries now that are involved. As of September, I don't know if that's gone up at the moment. We know that Japan are just about to join up. So at the moment, it's funded by Australia, North America, US, and Europe. South Africa are about to join, and Brazil are about to join. So suddenly we're starting to see a considerable interest occurring across the globe. And if you come from a country that isn't there, make sure you get involved quickly. How it all works, well, there's the funders at the bottom here. And one of the challenges for us is long-term funding for this, because you can't have short-term funding. We had that situation in the UK with Arts and Humanities Board. They funded things like live performances and archaeology for 10 years and then stopped the funding. That is impossible. So this has to be a new way of funding. So one of the discussions within the Commission is how can we keep this going on a rolling platform rather than grant by grant. There is the council, which is now full, and the initial part of that was elected or nominated by the colloquium. From now on, it becomes a community-driven process. The Operations Advisory Board is Juan's lot. There's a secretariat, which is at the moment, I don't know why the T's move, something like that, is based in Boulder, Colorado. The Technical Advisory Board, which actually does most of the hard work on the actual projects and working groups themselves. The Operation Advisory Board is looking after how organizations join in, such as universities, such as research institutes, and such as companies as well. And then we've got the interest groups and the working groups. So that's how it's all set up. And these are the first 4 to actually report on deliverables that reported in September. Now you'll see these are all background working groups. We've still got to see the user community starting to come through in this area, but these are the first ones that started. I would say there was some disappointment in what they deliver, but at least they're trying to do it. And you can see some of the users that they're claiming. Here's one on practical policy working group. The Plum, by the way, was the daily newspaper of the conference, if I remember rightly. It's all to do with low-hanging fruit and but anyway, this is their stuff. You can have a look at the practical policy one and see what their outputs are there. We are also, again, Juan was involved with this, that the European Commission adopted the EU open data rules just over a year ago, and that then got adopted by the Open Data Charter of the G8 group of ministers around the table, and that was a milestone for us. Now, the interesting thing there is if you go to the G8+5 group and ask them, the bureaucrats, what they think of the Open Data Charter, they'll look at you blankly. So there's actually some work to be done to convince the bureaucrats and civil servants that they actually have signed up to this. But so we'll see what happens. I've managed to lose a slide there, but the 5 principles we all know, I suppose. But this skills base is the thing that I'm really very interested in. This is a slide again that came out of Microsoft. But we need to define a lot more what we want and how we're going to get these data scientists, as we've been calling them. But they're very much a generic body of people of different attributes. And I think this is probably my last slide. Yeah, these are from the Dublin plenary just 7 months ago, where Tony Hay trusted to define these. I think these are too limiting, to be honest. But he looked at different levels of data scientists, and he talked about data engineer, data analyst, and data steward. You might like to have a look at that, because I think that is far too confining. I see the idea of a data scientist at one stage being somebody who does write data and code, yes, maybe, but actually somebody who is in the research group or does research themselves across different data sets to look at newer areas. So I think this needs expanding, and I think that debate is still out there. And I think that's it. Okay. I don't know what you want to do next. Any questions about the RDA itself or where it's going? I hate to say it, I mean, there's a huge amount going on, and I've only given you a 0.001% glimpse of what it is, but there are people around here who are involved. So, did you?
So, John, you had a very exciting demonstration and presentation, but it was a little bit too fast to make new slides. So is it possible?
Yeah, sure, yeah. Yeah, but if you do use them, there are 3 or 4 there from Microsoft, which I've borrowed, so just acknowledge them if you wouldn't mind, yeah. Yes, I used to say I'm sorry for my English, because it's not too understandable. No, very happy you should use them. I think quite a lot of them, certainly on the RDA itself, are knocking around on the RDA Alliance website. There's a lot of information on there, isn't there? And we are running that from Europe, so that's run from Italy, so it's in our hands, yeah. Sure. Okay. Release date? Good?
Okay, so, well, lunch is scheduled for 1 o'clock, and I guess that's fairly immovable. And anyway, I don't want to keep us from our lunch too long, but we do still have half an hour. So the next slot was for myself and David to come back to Parzen. So I will certainly give my little presentation, and then I think we'll see how much time we have before lunch and decide what to do. We were going to talk about the Parzen Centre of Excellence, and I'm going to give some reflections on the process by which we arrived at where we are. So I'm not going to say much about the structure or the formation of the Centre of Excellence, but rather offer some thoughts about how we approached the process within the project of providing a blueprint for a Centre of Excellence. Right, that's mine, I think. Yeah. So yes, the journey, how we got to where we are. One word which sort of fluctuates in and out of focus with respect to Parzen is virtual. Sometimes we refer to a virtual centre of excellence, sometimes just a centre of excellence. What we've never considered, of course, is a physical centre of excellence, but thinking about physical centres of excellence can shed some light on what an Parzen Centre of Excellence could be. So just looking at in my own country, here's a web page of a Centre of Excellence in Personalised Healthcare, which is part of the Institute of Biomedical Engineering in Oxford University. It's funded by the Wellcome Trust and the Engineering and Physical Sciences Research Council. So that's physical in the sense that there's an office, there's a building, and it employs staff. who are brought together and are presumably experts in personalised healthcare, and that's kind of declared to be a centre of excellence. Here's another example. Again, it's a building. You know, it really exists in the real world. The Isaac Newton Institute for Mathematical Sciences, which is at the University of Cambridge. But even though this is another physical centre of excellence, it's different from the previous example because the idea is it brings together mathematicians from all over the world to work on research problems. So rather than having a staff who are themselves excellent, it brings people together to do their excellent research. Looking a bit wider, if you start looking at networks of excellence, you find actually there's a whole constellation of words that are associated with these things. There's a network, there's a center, there's a hub. I mean, all these things really exist. You can find examples if you just do a bit of Googling, and it can be called competence or excellence or capability. Although I think the center of capability seems to be a term favored by management consulting organizations to describe their own in-house expertise. But clearly these things are, you know, they're different, and yet they have something in common. I mean, the lowest common denominator, I suppose, is that they're good at something, and there's more than one person or organization involved. But the different terminology reflects different models of how these things are organized. And of course, we mustn't forget that APARZEN never was operating in a vacuum. There are precedents which are much closer to home than the Isaac Newton Institute or the Personalised Healthcare Centre of Excellence. So there's the Impact Centre of Competence on digitisation of text. There's VCC 3D on three-dimensional modelling. The Presto Centre Foundation we already heard about, and no longer the Open Planets Foundation, the Open Preservation Foundation, which is perhaps the one that has the closest contact with APARZEN. These different terms are used, and there are various precedents, models that APARZEN could choose to follow or not to follow in various ways. So how do we make sense of these different options and precedents? Well, the first question, of course, is to ask, what is it for? Excellence. I think there are three things that the Centre of Excellence is trying to do in the context of APARZEN. One of them is develop the excellence in particular areas. I mean, not just in try to get better in everything, but to focus on particular areas and improve the state of the art. And in APARZEN, for example, there was the work on persistent identifiers and the work on knowledge modeling and representing gaps between the knowledge base and the designated community. So that was actually developing the excellence. Then there's structuring the excellence, the quote from the description of work, to give it coherence, cohesion and continuity, which of course leads to the common vision, one of the major outputs of APARZEN. The common vision has always been intended primarily to underpin the Centre of Excellence, but of course it's of interest to everyone outside APARZEN itself, because it reflects the collective understanding that we've reached of the field of digital preservation over the last 4 years. And finally, there's spreading the excellence. So the first two examples I gave, and particularly the Isaac Newton Institute, I mean, the idea there is that you bring the mathematicians together, they advance the state of the art, they I don't know, prove theorems that hadn't been proved before, and presumably publish the results. But they're not primarily concerned with spreading the excellence. You know, publication is enough to spread the excellence. In our case, we have to be rather more active in spreading the excellence. That was the whole point of our Centre of Excellence. So the motivation, and this is a diagram I've adapted from our most recent deliverable on the Centre of Excellence, makes it clear where the problems arise. So we've heard a lot about the data deluge. I mean, that we can take that for granted. We've also heard about the importance of value. What's the benefit that can be gained from this data, this information, particularly the long-term value. So, which information should be preserved and how to keep it usable, understandable, and accessible in the future. These are all points that have been made several times in the preceding talks. And in a sense, the Centre of Excellence is providing an answer to that, because those questions have many different facets. They have many different aspects. There's the technological aspects, there's the policy aspects, the social aspects, cultural aspects. So the Centre of Excellence is trying to bring all these together, to bring together a set of tools, services, consultancy and training structured in some way around the common vision, which will go some way to providing the answers to those questions, and in particular for wider communities, spreading the excellence beyond where it already was to be found. One of the approaches we used was this business model canvas. This is quite a popular technique. Quite a well-known technique. These 9 panels. You could ask, well, were we really constructing a business model? Wasn't that in itself making an assumption about the nature of the Centre of Excellence? In fact, the use of this canvas turned out to be a very useful exercise, whether or not you think of it as constructing a model for a business, because it obliged us to consider the interactions between these different panels of the canvas. First of all, to be clear about the value proposition, to understand the customer segments, who's the real market for this value proposition, what kind of relationships do we have and could we have with those market segments, what infrastructure is needed to support the offering. And then we can think about cost structures and revenue streams if that's an appropriate way of organising the Centre of Excellence. So this was quite a central technique that we used in a number of meetings, brainstorming sessions, and Tiger teams to try and develop our notion of the Centre of Excellence. Some of the questions that we grappled with, I've presented here. This was by no means the only questions we had to answer, but I think these ones are some of the most significant. Inside and outside the virtual Centre of Excellence, one model for a Centre of Excellence is of course something based on the Alliance for Permanent Access, which has members. So that implies a fairly sharp distinction between people who are inside and people who are outside. Now, does that distinction always make sense, or is it more blurred than that? Because, for example, some of the people who are inside may themselves be part of the market, and that's absolutely fine. So this distinction between inside and outside was something that occupied us. Understanding what is the demand and what is the market for what was another key question. There was a market research exercise conducted in this last year of the project to try and give us some quantification for understanding that. And then the blueprint for the Centre of Excellence. What are the options for what a Centre of Excellence could look like? a membership organisation with a very strong central organisation, some kind of looser affiliation. There are various options there, which will be presented as the blueprint in the final deliverable at the end of this year for the Centre of Excellence itself. And so, yes, so well, that brings me to the end, really. Here we are. This meeting is the culmination of the 4 years of work of A Parzen. So it's the end of one journey of the project, that is, and the beginning of another, going off into the sunlight. That was the intention of the shading there. Yeah, so that's my perception of how the discussions and the formulation of the Centre of Excellence have proceeded. Later on, we're going to hear some specifics about offerings within the Centre of Excellence, but I wanted to give a kind of narrative of how the concept has developed within the lifetime of the A Parzen project and some of the issues that we had to deal with. So thank you very much. Any questions? I wonder if what do you think we should do about, I guess lunch is fairly fixed, isn't it? And as I say, I don't want to delay people, keep people from... Okay, yeah, that's fine. Okay, so now I'll hand over to David, who's going to say not so much about the process, I think, but more about the substance.
Thanks, Simon. So what I'd like to do is link to the strange picture that you, I hope, saw when you were coming into this room, what it means, what its use is. But first, there's a bit of motivation carrying on from what Simon had said. One of the prime aims of A Parzen was to defragment the research that's been funded, was mentioned by the project officer Manuela, there you are, this morning, because a lot of thought, a lot of research, a lot of resources have gone into this, and as John said, we need results from that. But we know that there's a need to preserve and reuse. So reuse is now the key term, but it is difficult, and there is not a simple one-size-fits-all solution. So whereas for storage one might think that those problems are, if not solved, then there is a roadmap for how to deal with terabytes, petabytes, exabytes, and so forth. That's not really true for digital preservation. We have many, many pieces. A lot of money has gone into that, and we need to understand how all these pieces fit together. And also, as I think has been mentioned several times, for example, Michael on EGI and on the talks from the European Space Agency, there's a vast variety of types of digital objects out there. So new challenges will be presented to us, not just the familiar things that we often talk about. People tend to give examples of PDF or Word or the SAR data and so forth, but there are many other much more complicated and interlinked digital objects, intellectual objects that we will be asked to preserve because they will need to be reused into the future. So here are some examples. These actually are rather limited in the scope that they cover, but the one at the bottom, new complex digital objects, are perhaps the most open-ended ones. But even in the case of, well, medical records, there is constant technological change. There are so many issues that arise from one day to the next. Now, the difficulties are that there are many threats. Of course, there are some of the obvious ones. One of the things that I've been focusing on over many years is the loss of usability. And that, I think, is the thing which ties me back to what, in particular, John was talking about, namely getting value from the vast amount of money, not that's gone into digital preservation research, but that's gone into producing research data, which is a huge factor larger than the amount that's gone into digital preservation research. So there are many different challenges. Here are just some of them, and many options that if you look around, these are the things you might recognize, the systems that promote them, just keeping many copies. So you might think of locks. I would say that's not enough, because that tends not to allow you to overcome the issues about understandability. As time evolves, different software, different hardware, even different concepts come into play. And so to understand data from some time ago, one needs more than just the bits. I think Michael said that, and in particular it links into what John says, because if we are to get benefits, societal benefits, to fit in with the really big picture, so this is not just Europe, it's global, that's one of the impetuses of the RDA, then we need to do more than just keep and access the bits. We need to be able to use them. There are many examples from Microsoft. They undoubtedly, and many other software vendors, are doing a sterling job, but will they solve the problem? I think the answer is probably no. Even if one thinks about the difficulties coming with Microsoft Word, are there magic preservation formats? I think, again, the answer is no, because of this, the issue of understandability and usability. So we can go through many of these solutions that have been proposed, that have been the basis of many research activities, the basis of many solutions that are on offer. And I think in each case, the answer is either no or maybe. So this, and the last points there about the costs. One of the very important things for any funders of digital preservation, John touched a little bit on that, but I know that in the first version of the Riding the Wave report, the question about how all of this digital data will be sustained over the longer term was not touched. And it'll be interesting to see whether the new updated Riding the Wave has a solution. I suspect the answer is not. And one of the associated points is that even the costs of doing the preservation are not well defined. There are models out there, but in our work we've tested those, and all of those models seem to be very specific to the areas that they were created in, and it is therefore very difficult to provide the funders with the answer to the question, well, okay, you tell me it's got to be preserved, how much will it cost? So the implications are, now I think most of those here will accept that these are difficult challenges, and one needs, and I guess this is where a parson comes in. there are many pieces of research, many things on offer. How do they fit together? None of them provides the solution to everything. There are new challenges coming up, and yet, all of those results out there probably provide the answer to something. Because nobody is stupid out there. They did something for a purpose that suited their particular purpose, but there are many other challenges out there. Is what they've done applicable to those new challenges, or is something else needed? And indeed, if somebody comes to me, to you, with a new type of digital object, which of those solutions has a chance of working? So that's what we tried to address in APARS, and try to understand the vast amount of research that's gone on in digital preservation, all the solutions that are on offer, and we wanted to be able to provide sensible advice to say, well, if you've got this particular challenge, then that sort of tool might work for you. But in fact, everything is so interrelated. The costs, the services, the risks, the preservation techniques, all of those are interrelated. And so we needed some sort of integrated vision to try to bring all of these things together. Now, we've done this in terms of the model you saw out there, but there are many models, and they've been proposed about digital life cycles, essentially. This is one collection from one of those blogs out there, the Library of Congress. There's been another report that brought together, I think, about 40 or more different models. So many of these things, that at least has business requirements in the middle there, but they mostly focus on the research life cycle. And of course, they did that for a good reason. However, none of them really provide the answer to the question which often has been asked, and that is, so there's the reference to these models. Who pays and why, especially if the payback is not immediate. If the payback's immediate, then there's no particular problem. But we do have to think, if we believe that digital preservation is of value, is of interest. To some of us, it's in some ways an academic interest. To others, as we heard from the European Space Agency, there are vital needs, vital societal needs that need to be addressed by the techniques of digital preservation. But still the question is, who pays and why, and where do the resources come from? And this is a question not just in Europe, as John said, but worldwide. So this is a very important question, and that's why we put together this strange-looking model. It is a life cycle of sorts, but it's built on the ideas of value. So you'll notice immediately that preservation is not at the top, it's not at the bottom, it's out there to the side. And there's a good reason for that, because the workflow, in a sense, was that, of course, these things are created and used initially, and then preservation comes into play. Isa said it has to be brought in as early as possible, and that was good by Mikhail. Now, there are various aspects to digital preservation. I'll come on to those smaller boxes later. But the ultimate test of preservation, if you follow the OAIS reference model, is usability. So just saying I'm preserving this is, in a sense, meaningless. It's certainly untestable. So you have to, what OAIS does is to talk about the usability and understandability to a particular community, the designated community. So a particular repository has to look after a particular piece of data, and I'm running late. And so they define a community that they are guaranteeing will be able to understand and use the data. On the basis of that, we get value. And if we can understand that value, then we can build business cases, business models which generate payback over some time scale. And that benefits society as a whole, we hope, but also answers the question who pays and why for that particular digital object and related objects. But I'll come back just to one particular point, and that is if you look at the coming out of preservation and moving into usability, there are things labeled transform and representation information. The point there is that this gives us, those of us who are interested in digital preservation and want to provide solutions, the opportunity to increase the value of the data, because what we have to think about is what the, in preservation terms, is the designated community, so the concepts, the software that a particular community has, and we need to understand those in order to make sure that the data is usable by that community. But we can broaden our view and think about other communities and therefore understand what additional representation information might be needed that increases the usability or broadens the community that can easily use that data, thereby increasing the potential value and allowing us more business cases and business models. I hope you'll hear some more about that from Ruben this afternoon. So that's the basic idea, and what this allows us to do is to link, the integrated model allows us to answer the question who pays and why, and also to integrate all of the different pieces of research that have been done using a lot of that 100 million euros that was talked about. Because any aspect of digital preservation involves things to do with governance, costs, rights, authenticity, value. All of these things are interlinked, and by using this model, and on the website these things are clickable, and you can drill down into all of the research that underpins the this model. And the analyses that we've done in Aparsen in terms of what works where. So this is quite a key picture that helps us to do the next step, and that is to provide the consultancy training and services, not just to be done by me, but to be done by the experts in digital preservation distributed across many different organizations. But if you get people from different organizations coming together, then it's possible that they'll take rather different views on things. So what we need is some sort of consistency based on the outcomes of the Aparsen research built into this, this integrated view of digital preservation. So that's that's the other side of this. It helps us answer who pays and why, but it also allows us to provide something that I think is unique, namely, and defragmented, namely consistent training, consultancy, and services. The services are provided not only by work that's been done within the organizations or from previous projects, but also you'll hear this afternoon about the SIDIP project, which plays a key role in those services. Now, I don't think I'll go through these. The slides will be available. Each of those steps has a first level of analysis that indicates why these things are important. But if you drill down, then a whole lot of further detailed answers are provided. So you'll be able to look at these slides on the website offline, and all of the resources, the clickable image, all of the analyses are available on the APA website. So we are a little bit late for lunch, but not too late, I hope. So I'll be around for both days, so please stop me and talk about this. So I think we should go for lunch now.
Yes, 1 hour for lunch, yeah.
Okay, 1 hour for lunch, thank you.